To this video where we started in part 1 finding or verifying the divergence theorem. So in part 1 we find the triple integral of def of f dv. In part 2 we need to find the flux and we need to check if our answer is the same. However, just a correction from part 1, by mistake I wrote this as 2, so the final answer has been changed. So please go back to part 1 and correct this one here. Now, in order to find the flux, we need to find the parameterization of this curve. Since we have only one equation, which was z equal x squared plus y squared, one of the parameterization, I will take x equal to u, y equal to v, and now z is u squared plus v squared. Now, this is a very good parameterization that we need to use. So in order to find the tangent or the normal vector, we will find the vector ru, rv, and we'll take the cross product. So this is uv, u squared plus v squared. Now ru is just 1, 0, 2u, rv, which is just 0, 1, 2v, and now the cross product is just minus 2u minus 2v, finally with 1. So in order to find the flux f dot ds, we will find the vector here that we have it in the question, which is y squared z cube, comma 2yz, comma 4z squared. And we will do the dot product with the normal vector, which is negative 2u, negative 2v, 1, and then we write dA. Now we have to find this double integral here, so all what we need to do the first with the first, so we get negative 2u. Now for the y it is v, so it will be v squared. Now for the z it is u squared plus v squared power 3, plus second with second, so again I have not plus, it would be minus, it would be 2v, and instead of y I will write v again, so it would be v squared. And instead of z, I will write u squared plus v squared. Finally, the last one will survive as it is, dA. Of course, if I look at the region that between ru and rv, this is just would be a circle of radius 3, because it has a top where u squared plus z squared equal to z and z equal to 9, so it's a circle of radius 3. I will shift to polar coordinate. This would be 0 to 2 pi, 0 to 3, and now this one would be minus 2 r cosine theta, r sine theta squared, r cube, or r squared cube, so it would be r power 6, minus 2 r sine theta square, r square, and finally 4r square, which is power 4. And now all what we have to do here is, instead of dA, we write the value, which is r dr d theta. And we evaluate this one directly, straightforward. It will take some time to evaluate this one. This is not an easy integral to be evaluated directly, but again, we can do it and we can find the answer and we can verify that this answer is